everybody. Nice that you all attended to my talk about Flutter Web today. But I will start with a question, and I want to know how many of you have already tried the Flutter Web support. Let's raise a hand. Oh, nice. So already a lot of you have tried it. So that's really cool. But the second question is, how many of you are also using Flutter Web in a production setup where you run it live for your users? Okay, I see. So there are less people doing that. Probably there are some cases. So let's see if my talk can make this option more attractive for you. Because we want to see how Flutter Web can really be used in action. So how can we use it for a reproduction setup? So hey, again, my name is Joachim Böhmer. I'm the lead developer of the for Pics team at Lotum, and we are a small mobile and development studio from the center of Germany, but our games are used by quite a large user base. And also the host of the Programmierer podcast, and we talk about Flutter topics now and then. So if you are a German attendee, you can also give it a listen. And unfortunately, it's only in German language, so all the English-speaking people cannot really join it. And you will find me on Twitter and GitHub under the handle Captain Koala. So today we will have a look at Pics Web, how we used Flutter Web for the app Pics on Word. And this app was mainly or firstly developed as a native Android and iOS app. And it was one of the first apps that we developed. So the app is already quite old. It was already initially published in 2012. So we will celebrate our 10th anniversary this year. At that time, we used a quite common setup. So we just had a separate code base for iOS, and we had a separate code base for Android, and we had a dedicated developer that was working for each platform. And we did not expect the success that we had with the app over the years. So even today, our app is played from 1.3 million users every day, and we have very big fans that are playing our games for years already now. In 2017, we also ported our mobile app to the Facebook Instant Game platform. And this is a completely different environment where we're using browser technologies like HTML5 and Pics to run the app on the browser. In 2020, we decided to do a rewrite of our native app. The problem was that we had a big spread in our code base that came in over the years. And we also had an inconsistent design between the platforms because some of the features were ported for one of the platforms, the other one were not. We had new design iterations that only get implemented on one platform. And it really turned out that we had a really slow development of new features because every feature had to be implemented for both platforms. So in 2020, we decided to reroute our whole native app into Flutter. And this was really nice because we had a really nice developer experience right from the start. And we also achieved a much better user experience because we could provide a consistent design for all the users, a consistent look and feel. And we also brought a lot of features that were previously only available for one platform that could now be used for both platforms. And the biggest benefit was that the whole team could now work on one shared code base. So it was much easier to avoid knowledge silos where only one developer knew the internals of one platform. And we also had much more communication about new features and the technical aspects of the platforms. And it was much easier also to share the responsibility for the complete technology stack now between the team members. So in the end, we achieved a much faster feature development with the Flutter app that we are now running for the Pics game. So in the end, we really fell in love with Flutter because it provided such a good experience that we really try to use it wherever it is possible right now. In 2021, we decided also to rewrite the instant game for the platform. And as I mentioned before, here you have a different setup. So you have to use browser technologies. And After the initial success of our app on the Instagram platform, we had a constant decline of our user base because a lot of the features that we brought to the native platform have not been ported to the Instagram platform. And also news APIs that were provided by the platform, like new APIs, like tournaments and stuff like that, we could not use because we didn't have the same functionality in the native app. So there were a lot of opportunities that we missed that we wanted to catch up with. And also our software stack using Pics.js was quite outdated. So we thought, okay, we will not rewrite this using another browser technology. Let's think about how we could do that. Our first impression, or what we have to look at first of, what are the implications, the requirements that come from the Instant Games platform? So what the Instant Game platform wants to provide is the instant gameplay of games. So we only have a platform where each game is just a click away, where the user has no strong commitment for playing your game because everything is just located quite besides the other games. And we also, what the Facebook always stressed out, that we really need a small bundle size. And the bundle size includes the size of the game itself, of the engine, and also all the assets and the resources that we need to download. And the less data is transferred over the wire, the faster the app is rendered on startup. And the faster the startup time is, the less users are bouncing off our loading screen. So it is really an important part that we try to reduce the bundle size as much as possible. What we also have on the Facebook Instant platform is that we have a lot of low-end devices. So we will encounter a lot of users that doesn't have a good device at hand, but we also need the ability to provide the ability to these users to play our game in some form. So when we thought about rewriting the app, we first thought we do it in Vue.js, because Vue.js is something that has a very small bundle size, so it's only 330 kilobyte when it's compressed on the wire. We have a very good developer experience with that. We have a good knowledge base in the company because all of our other games are developed using Vue.js, and we can achieve a very good performance in that aspect. And we also had a working proof that this is really working very well, because we have implemented a share client that was using the Vue.js technology. When thinking more about this, we thought, okay, but this is not a good option for us, because now when we do the rewrite in Vue.js, we have a split code base. And what we can achieve with doing it in Flutter is that we have the same code base for the native app and the Flutter or the instant game in most parts of the game. And we also had other projects that had a separate code base, and they really had big problems when they had to maintain the app in the long run. Also, the introduction of a shared code base introduced or meant less mental load, because we didn't need to switch the programming model and the programming language when we were developing for the different platforms. So what we were expecting when using Flutter, that we would be able to do a much faster feature development for the targeted platforms. One point that we had in mind, that the Flutter Web platform is still quite young, so it's not that mature than the native or mobile support. And there might be a good chance that we encounter some obstacles while we're implementing the app. So now let's have a first look how Flutter is rendering its contents on the web. Probably most of you know that we have two options when it comes to rendering on the web. The first option is the HTML renderer. And the second one is the CanvasKit renderer. When you build the app with the web render autoflag, the HTML renderer is used for mobile browsers, whereas the CanvasKit renderer is used for desktop browsers. And the HTML renderer, it only uses Canvas or HTML and JavaScript, whereas CanvasKit renderer, it uses also WebAssembly on the side. And because the bundle size was very crucial for us, it was much more interesting for us to look at the HTML renderer. So when you look at the size that you have for a normal setup, you see that the HTML renderer creates a bundle size of about 1.3 megabyte for a blank project. That is about 380 kilobytes when it's transferred zipped over the wire. And we have that same basic size for the CanvasKit renderer as well. But what we also have on the CanvasKit renderer side is that we also have the Skia CanvasKit runtime in WebAssembly, and that is about 7 megabyte big, and it's still about 2.9 megabytes when it's transferred over the wire. So that is quite huge, and therefore for us it was quite clear, okay, probably CanvasKit is not the right option that we can go with. So at first we had a look at the HTML renderer, and now let's see how this works under the hood. So the HTML renderer uses the whole entire HTML document as a drawing surface. The Flutter Canvas API does all the drawing operations of shapes, images, and text elements. Flutter does the layout calculations, and the HTML renderer will just position or put absolutely positioned DOM elements on the canvas. But depending on the complexity of the drawn components, the HTML renderer will do some switching and will create a set of different DOM elements. It will, for example, create standard DOM elements for image elements like you see here for the images up in the grid, or it will create paragraph elements for all the text blocks that are available on the site. And it will also create custom web components. For example, here you can see a rectangle with rounded corners, and this is a custom web component that will just be filled with the corresponding parameters. But when you also inspect the DOM, you will see it will create a lot of canvas elements. And probably who's working with web or Vue, you know that a lot of canvas elements in the DOM means you probably will not have a good performance, because this is very heavy for the browser to render. So what about canvas elements? When does the HTML renderer draw a canvas element? We had the requirement from our designers that we keep the look and feel of the native app, and that none of the decorations, none of the complexity, the UI design is changed or reduced. So we're just using over the whole app the decorations that we have, and as soon as you introduce too much complex decorations, you will see that the HTML renderer is creating canvas elements out of it. So here's an example of an decoration object, a decorated box that will lead to a canvas element. So as soon as you have some linear gradient on a box and you apply some box shadows, you will create a canvas element on the DOM. And this was especially a problem when having animations and endless scrolling lists, because then the canvas elements really got sticky. So our first approach was that we introduced a technique that we also used for different web games. And that meant that we wanted to reduce the number of decorations needed and replace them with images, because this is something that the web browser is very good at. He can render images at very fast scale. And our approach that we took, because we have a lot of components that need an asset in some stretch form, that we take the image and make it a 9 slice. And with a 9 slice, this is supported by Flutter by using the center size property of the decoration image. And HTML renderer will create 9 absolutely positioned div elements with a masked background image on the DOM when you do that. And this again leads to a problem, because when you create too many images on the DOM, you will also result in a bad performance. So what we did in the first step, that we created a custom decoration image, and this custom decoration image had the possibility to eliminate the slices when the horizontal and vertical center slice bounds became 0. So with this approach, we were able to draw only 3 slices when we only, for example, needed to stretch the component vertically or horizontally. So what we implemented, it was a basic switching of the render path on the basic components that we introduced for our app. So we had the normal rendering path for the native app, where we used the decoration images or the decorations of the decorated boxes and stuff like that. And we had a different rendering path when we were running the app on the web platform, or we just use the corresponding image and center slice properties that we also handed over to the components. And the concept prototype that we did with this approach was quite promising. So we had quite a promising performance, and every song was running quite smoothly. But at the end, we still had unsolved problems. So what we had is that we introduced a much higher complexity for the developers, because we always had to ensure that both rendering paths for all the components were supported. So every time we developed a new component, we had really to think about, okay, is this something that we have to provide and have to support in both rendering modes, or is this something that is only available from one platform? And also the designers had to create and export the corresponding 9-slice images. And the more bigger problem was, every time you introduced or you developed a new component, it could happen when you created a decoration object that it resulted in a new canvas element on the DOM. So you always had to check your DOM during development to check if there were any new canvas elements introduced in the DOM. So also with our improvements that we did with the 9-slice, that as soon as we got too many components on the pages that used, for example, those images, those 9-slice approaches, we also realized that we had a significant performance impact on that. And this led to the case that the app was still janky on popular Android devices that are used heavily already now, or still now. So so at some time we had to pull the ripcord and say, okay, the HTML render approach is not something that currently leads to a satisfying result for our type of app. To our luck, we now had the possibility to just switch the flag in the build command and use the canvas kit renderer instead. Still, we knew that we had this bigger bundle size that was introduced by that, but it was the only approach that we were able to take at that step. So let's see how the canvas kit renderer operates under the hood. So canvas kit is in fact a port of the Skier engine to WebAssembly. So when you look at the files generated in your build folder, you will see a canvas.wasm file that contains supported Skier engine. And you will find another file, canvas.kit.js, and these are just the corresponding JavaScript bindings that the Skier engine needs, that you need to call the Skier engine from the JS side. And on top of that, you will definitely find also your main.js file, which includes your source code as well as the Flutter engine and the Dart runtime. And what happens now is that the Flutter engine creates a canvas element, and this is mainly the only element that is created with the canvas kit renderer on the DOM. And this is handed down to the canvas kit WASM module, and there it is wrapped in a Skier surface. And the Skier surface allows us to directly paint on it, and all the pixels painted on it are directly drawn to the corresponding canvas element. So Flutter only performs the corresponding runtime layouts, and the Skier engine performs all the drawing operations needed, and these are directly mirrored to the corresponding canvas element on the DOM. So when switching to the canvas kit renderer, we saw that on most desktop browsers, we really had a comparable performance that we had in native. We also see that for mostly all current mobile devices, we had quite a good performance, especially for the devices that we had in our test pools. And the best part of it was we could use the same code base for running the native app that we used for running now the instant game. But when we tested the canvas kit renderer on low-end devices, and like I said, for the instant game platform, it's quite crucial that we also take this this number of devices or these devices into account. We saw that the performance was not that good anymore. So we saw janky animations, also screens becoming seeming not to react to any user input, and overall the performance was not bearable for such a big part of a user base. So what we did is that we also introduced again a second rendering path, where we said, okay, we just reduce all the complexities that are introduced by decorated box and stuff like that. We just paint the basic interface of the UI, and this is what you see on the screen right now. So you can still see it's the app, it's still playable. You can still identify what are the corresponding components that I have to interact with, but it's really reduced to the basic components, to the basic layout elements that are needed. And what we also did for this approach is that we said, okay, we remove all transitions and animations that we have in the apps, or most of the animations, not all of them. So yeah, we have those two rendering paths in the basic widgets. So we have a switch where mostly only the basic widgets need to decide, okay, in which on which platform am I rendered, and then it switches the corresponding output to do the drawing in one or the other way. One problem that we faced that we needed to define the runtime location of the canvas kit, because the security policy of the Inkscape platform was preventing us of using that default location of the canvas kit runtime that is on package.com. Fortunately, you have the ability to define the canvas kit URL yourself when you use the Flutter Web canvas kit URL .define when running a build. And you can change the runtime with that .define. To really also increase the speed up the loading times for the app, we took another approach that we added some link elements into the header where we say, okay, we preload the corresponding canvas runtime so we don't have to wait until our main.js file is loaded and is executed, because then it first starts to load the main.js file. So in this case, it already starts to load the corresponding canvas kit module when it has interpreted the header, and you will reduce, or you will get some milliseconds time to do other stuff. But you have the problem that not all of our browsers are supporting WebAssembly. And it's in some cases that WebAssembly is just blocked. And that can be, for our user base, it was that about 3% of our users were not able to run WebAssembly. And either it's because they have deactivated the WebAssembly support in the browser settings themselves, or that they have installed an ad blocker that is preventing the access to WebAssembly. That could also be the case. We tackle the problem that we fall back to the HTML renderer when we identify that. So we just have a small script that is running in the index file, in the index HTML file, that checks if WASM is supported, if WASM can be addressed. And if that's the case, we will just use the standard canvas kit renderer. But if that's not the case, we will fall back to the HTML renderer. And we can do that by setting the Flutter Web renderer property on the window object. This is also the information that Flutter uses internally to identify which renderer he's currently running on. And in this case, the whole UI is just rendered in low detail mode, because with the HTML renderer, we don't have the ability to draw high complex components, and therefore, okay, the user gets the reduced functionality that we have in the other rendering paths. Okay, some other techniques that we have to introduce to achieve native performance was asset preloading. And normally, when you're using the canvas kit renderer, you see that some assets are lagging when you start the app. You can see that visually because the images are popping in one after each other. So you can see the part of the screen is stretched because the image below for the lower tournament mode, it just entered a little bit later, and all the images are a little bit delayed. And this is something that really doesn't feel native. The biggest problem here is the images have to be loaded over the network. So on the native app, the transport over the method channel is quite fast. So even though you're loading your images just in your widgets, the transport will be so fast that you don't really feel or see that the images take that long time. But as soon as you're working with images loaded over the network, you will see that you have that impact. And it really depends on the network conditions that you have. This is less striking in the HTML renderer because there we are using the capabilities that the browser has. But for the canvas kit renderer, it was really striking. So what did we do for asset preloading? So what we had, or what we introduced, were page-wise preloaders, and we put it on the level of the page because the page knows best which images and sounds are included on all the widgets that it uses, that it imposes, and also what images and sound which assets are used by itself. We also provided the ability to pass the root settings to this loader so that we can handle the initialization of contextual resources. That means resources that are depending on some kind of root parameter. And then you will add a central preloader registry where all those loaders are installed on the root objects. And this is also put besides the corresponding the root generator, where you generate the roots so that those definitions and mappings are always in sync. And whenever the base page is initiated, we always preload the assets needed for all the subpages that can be accessed from this site. So when you come to a page, we just have a programmatic call to preload all the assets that would be needed for all the routes that would be probably addressable from this base page. This is quite an effort, but this is the only way to really achieve that we don't need a loading spinner between the pages, or that we do some other kind of preloading mechanisms at start of the app. What you can help to maintain or to easier maintain your assets is that you use a package called FlutterGen. And FlutterGen will generate some kind of nested asset registry as code for you. And in this way, you will get a lot of codable resources that you can directly use when you're, for example, instancing a widget or stuff like that. And the big improvement of that is that that it heavily improves the maintenance, because you have auto-completion when you're designing widgets, and it also leads to a compile time error when you remove a widget from your asset folder. And this will not be something that just pops up during runtime because you forgot that you removed an asset that is used somewhere. So in this case, it's really easy for you to keep also the preloading of assets and the assets that are really used on the corresponding pages in sync. So animation jank. Animation jank is something that you probably also know from the other platforms. And this is something that we really didn't have in mind when we were developing for the Flutter Web platform in the first case. So what you will see with animation jank, when you run an animation for the first time, they will be jerky. So as soon as you continue to run the animations, they will improve every time you run them. But for the Pics app, it was especially notable when we are doing page transitions, because a lot of the elements are moved around and pushed over each other. And it seems that Skia is only performant when it has access to the corresponding shaders. And if we want to execute fluent animations in some way, how we have to provide those shaders to the runtime. But the generation of Skia shaders is quite heavy. So when this runs on the first time you run the animation, you will really see that the app will be stuttering. And this problem was mostly known for the iOS platform, since it was moved to the Metal graphics engine. So probably you also know who's developing for the iOS platform what is the corresponding workaround to mitigate this problem. You're pre-building the corresponding SKSL shaders in integration tests and just blending them with your app when you're building the app. So here's a video that shows how janky the animations were. So when you do a switch, you see, okay, the app is really stuck at the moment, and this is really on a good device. So this is something that really, for a first-time user experience, this is not something that we want to provide to our users. Unfortunately, the option of pre-building the SKSL shaders on the build phase is not possible for Flutter Web at the moment. So we had to come up with some other ideas. And this idea was that we warm up the transitions on startup of our app in the background, because we have a loading spinner that is running. And what we do in one approach is that we just use the normal push operations of the router, and we reduce the duration, the transition duration, because we realized in our test that it was not important how long the duration was really going. We could also use a much slower or shorter duration to do the transition. It was resulting in the same pre-warmed shaders that we were having when we are exiting the page later on. And we are doing this for all routes that are accessible from the main entry point, with which we are currently accessing the app. In a second approach, we also run the transitions behind the homepage. So all the apps that we are previously pushing over the router, we also build them in a stack behind the app, and we will warm it with an additional part, with an additional approach in the background as well. With this approach, we had a much better first-time user experience that we called experience. But what we realized is that both warm-up strategies were necessary to really provide the best experience for both platforms. So the effect that we had was much bigger on Android devices. And what you can see now here is the final result of the app, or with the preloaded and pre-warmed shaders behind the homepage. So everything is now running smoothly, and also the spinner, it only takes some milliseconds to really run and pre-build the shaders in the background. What could be future optimizations in this area? So definitely it would be good to have the support for the warm-up RP also on the web platform. Then we could call the shader warm-up on startup. And this is something that is quite possible. We talked to the Flutter team about this, and they said, okay, it's probably doable that we introduce this quite soon. What will be better also for the future is that we have the ability to rebuild the shaders also integration tests like we do it for the native app, and that we load this on those shaders on app start. So now you saw that we have this two different rendering paths that we needed to address. And the one option how the user can switch between those rendering paths is that we just have a toggle in the settings where you can switch it himself. But we also wanted to provide some mechanism that this rendering path is determined already at startup for the user. And we do some device classifications. And what we do here is that we try to identify which GPU model the user is currently running on. And with this GPU model, we can do some device model classification, because the user agent gives us quite good information which device model is currently used by just looking at the user agent OS. But for iOS, it's not that, it doesn't provide you so many information, so you have to implement your own inspection of the screen ratio, of the device pixel ratio, to really determine which iOS device is currently used. And this information is tracked via some kind of tracking tool, so you can have some inspection, or we're doing it right now, to really identify what are the devices that show bad performance. And we are still in the process of analyzing and defining those clusters. So here's some numbers that are just brought to you, where you can see, okay, what are the corresponding warm-up frame rates that we see for some kind of devices. You can see, okay, all the iOS models, they have quite a good performance. When it comes to the older models, it also get worse. But for the Android device, it's much worse. And this is also what we saw with the animation jank, that we had a much bigger impact when we were doing this for the Android devices. And also, we have another metric that we can see, where we can see that the warm-up duration that is needed is much slower for the Android or iOS devices. And for most, there are some Android devices that are also quite good, but there are also some Android devices that really has long warm-up duration phases. And this is still something that we need to investigate, why it takes so long on some Android devices. So in the end, we will probably hopefully have a package that we can also open source, where we have some specifications, some definitions, what we identified as devices that are not that good for running Flutter Web, that maybe can be utilized by other projects as well to do some kind of switching in a similar way. So let's come to the resume. What did we like about using Flutter Web for our instant, or for the instant game, for our game, for developing our game? And what we really disliked, sorry about that, is that we had a high initial invest to really make that feasible for us and to make it work. And we have still ongoing invest of identifying, okay, what are the pain points that our users are facing the most right now. We definitely need to improve the web support. So at the moment, it feels like the web platform is not that can be so used so widely throughout on all platforms, on all devices that we want to address. And we definitely still have a performance gap to native. And this performance gap is quite close now using the CanvasKit renderer and with all the strategies that we and approaches that we used to really improve the performance from that aspect. But we still also have visual glitches. So like text rendering is not complete on some Android devices. So some problems on the skier engine on the CanvasKit side that still need to address to make it fully work on all devices. But what we really liked at the approach is that we now have a large common code base that we can share between the projects or the different platforms. So it's much easier for us now to transfer one feature that we developed for the Instagram platform because, we also have very short deployments cycles. We can just launch a new app and we would directly receive the results. And it's much better for elaborating new features on the Instagram platform and just transferring those results to the native app afterwards. And we also get the possibility to develop the apps for new platforms. So there are a lot of platforms out there where HTML games are upcoming. And we now have a code base where we can, with some further improvements, say, okay, we are ready for launching our game also on these platforms as well. And in the end, it definitely brought back the joy in development because before, with using those shared code bases, it was always a hassle to tackle the complexity, to concentrate on one platform. And with the shared code base, it's much easier just to say, okay, I have a feature and I just port it over. I do some small adaptations are always probably necessary, but most of the components can be reused. And you can concentrate as a developer on developing everything in Flutter. So this is what we really like about Flutter and this approach we're taking. So thanks a lot for your time. And if you have any questions, there might be some time left to do that.
Thank you first.